Hello, and thank you very much for attending this presentation. I'm Armin Kiebele, working at the University of Kassel in Germany. In the following, I will summarize part 3 of 20 years of swim start research at the University of Kassel, mainly concerning attempts to optimize relay starts and their corresponding changeovers. In fact, in addition to research on the biomechanics of individual starts, my workgroup and I have also conducted studies on relay starts. These studies focused on the specific characteristics of relay starts on the block, on changeover strategies, and on performance gains during the swimming phases. For example, in 2008, we were asked by coaches to improve the changeover behavior of German junior swimmers ahead of the 2009 European Junior Championships. Based on the results of a previous study in 2007 on the key biomechanical parameters of individual swim starts, we were interested in comparing feedback on peak horizontal force with changeover time feedback in relay swimmers. As a swimmer's attention can only be focused on one of these two parameters, it was interesting to find out which source of feedback would be more effective for relay start performance. 26 junior male and female swimmers participated in the study prior to the 2009 European Junior Swimming Championships. Previously, to our knowledge, researchers had only looked at training interventions to improve changeover times as part of the overall relay team performance. Remarkably and unexpectedly, the German junior women's 4x100-meter freestyle relay team won gold with a new European record. Completely by surprise, the German junior men's team won a bronze medal. Our OSB-9 portable force measuring start block, center left, was again used for the data acquisition to assess the start time and peak horizontal force. The OSB-9 force measurement block was connected to a Sportronic contact mat to analyze the changeover time. Finally, the relay start performance was assessed by the time between the incoming swimmer's contact with the wall and the head passage of the outgoing swimmer at 7.5 meters, recorded by an underwater video camera. Relay arm swing starts for a 25-meter sprint with the same outgoing incoming pairs of swimmers were analyzed. Following a pretest, 2 training sessions on 2 consecutive days with 3 videotaped relay starts were assessed, followed by a post-test. For the peak force feedback group of 6 female and 7 male junior swimmers, performance feedback was based only on peak force information after each relay start. For the changeover time feedback group of 7 female and 6 male junior swimmers, performance feedback was based on changeover time only. Again, 2 training sessions on 2 consecutive days with 3 videotaped relay starts were examined, followed by a post-test. Here are the results of our study. When examining the pre-post differences, 2 significant group main effects were found for horizontal peak force and relay start performance. While both feedback groups, male and female, significantly increased their horizontal peak force by approximately 12% and 13% respectively, the male changeover feedback group decreased their horizontal peak force. Interestingly, all groups significantly improved their changeover time, meaning that although only horizontal peak force was fed back, the force feedback group also improved their changeover time. The relative changes ranged from 46 to 64%. Taken together, the actual start performance of the force feedback group was clearly superior to the changes resulting from the changeover time feedback. Most impressively, the improvements made by the female force feedback group averaged to 0.22 seconds per swimmer, adding up to 0.66 seconds across the relay team. This graph shows the reduction in changeover times between the pretest and the post-test assessments. It's worth noting that peak force feedback resulted in similar improvements in changeover times as changeover time feedback. In contrast, peak force only increased in the peak force feedback group, as can be seen across the different assessment times. Finally, on average, the relay start time to 7.5 meters decreased by approximately 0.2 of a second for each male or female swimmer of the peak force feedback group, adding up to, theoretically, 0.6 seconds for the 3 relay swimmers in a team. In a previous study on relay start training in 2009, we examined the effects of just one training session on arm swing parallel relay starts versus single-step relay starts in 16 elite German male swimmers. Again, our OSB-9 mobile force measurement start block central left was used for the data collection to assess start time and peak horizontal force. To analyze the changeover time, the OSB-9 force measurement block was connected to a Sportronic contact mat. Finally, relay start performance was assessed by the time between the incoming swimmer's contact with the wall and the outgoing swimmer's head passage at 7.5 meters, as recorded by an underwater video camera. Participating swimmers who had previously used the arm swing start in competition were divided equally into a one-step start group and a group that retained the arm swing start. Only one training session was used to determine the effects of a short-term intervention, as is often the case before competition. As a pretest procedure, 4 relay starts with the same incoming partners were analyzed. The block approach of the incoming swimmer took place from a distance of at least 7.5 meters. The subsequent relay start performance of the outgoing swimmer was recorded until the transition to the swimming phase, which was at least 7.5 meters away. Any false start, for example an early start, was repeated. No feedback was given on changeover time and peak force during the pre-test and the post-test assessments. The intervention consisted of 3 practice blocks with 3 relay changeovers for both groups, lasting overall approximately 1 hour. For each of the 3 trials in each block, video feedback of changeover performance and horizontal peak force feedback were provided. Changeover time was only provided for false starts. The results of our short-term intervention show that both groups were able to reduce the changeover time by up to 50%. The overall training effect was highly significant. However, no group-specific differences were found. Notably, the improvements in the changeover time did not transfer into a significant improvement in the relay start performance. In fact, there was a tendency for a decrease in overall relay start performance as measured by the time between takeoff and the head passage at 7.5 meters. While single-step starters showed a tendency to improve their relay start performance, arm swing starters showed a significant decrease in performance. Consequently, a nearly significant interaction effect between the intervention factor and the training group factor was found. Finally, there was a tendency for an increase in the peak horizontal forces. Overall, in conclusion, it appeared that switching to the single-step start had a greater benefit on relay start performance than remaining with the arm swing start. Unfortunately, due to the small sample sizes, the results just missed the level of significance. As part of a project funded by the German Federal Institute for Sport Science to improve relay changeovers in German relay swimming teams, for the first time, we conducted a training effectiveness analysis to investigate how our training procedures affect the performance of German relay top swimmers in relay competitions. In the first step, video footage produced by our colleagues at the Institute of Applied Exercise Science in Leipzig, Germany, was used to evaluate the most preferred relay start techniques at the European Short Course Swimming Championships in Eindhoven 2010 and the World Short Course Swimming Championships in Dubai as well in 2010. The bar chart on this slide shows the percentages of the different relay start techniques used during the changeovers in the final heats of the relay competitions in Eindhoven in November 2010, obviously not including the first swimmer. In the video material viewed, 82% of all changeovers could be analyzed. At that time, parallel arm swing starts and single step starts were most common. A similar frequency count was observed when analyzing the final heats during the World Short Course Swimming Championships 2010 in Dubai, likewise not including the first swimmer. In the video material viewed here, 94% of all changeovers could be analyzed. Again, parallel arm swing starts and single step starts were most common. In the second part of the project, we wanted to improve the changeovers of the German relay teams for the 2010 European Championships in Budapest and the 2011 World Championships in Shanghai. The procedures and corresponding information for the outgoing swimmers are shown on the left side, below with a horizontal force curve during the takeoff from the block in the upper part and the horizontal velocity curve in the lower part. The video image on the right shows the incoming swimmer's approach to the wall. All this information was provided to the swimmers during the training sessions. In total, from the results of the 2010 European Championships in Budapest and the 2011 World Championships in Shanghai, 73 data samples from German swimmers were analyzed compared to 700 data samples from swimmers from other nations. The timetable for our training interventions is shown on this slide. In preparation for the 2010 European Championships in Budapest, 20 training days were scheduled, with a total of 1,118 relay starts, of which about one-third included an incoming swimmer. In preparation for the 2011 World Championships in Shanghai, 23 training days with a total of 1,358 relay starts were scheduled, with almost 40% of them involving an incoming swimmer. Approximately 30 swimmers were involved in the training programs. 22 of those participated in the relay races during the championships. In total, 21 training days with 830 relay starts and 528 changeovers were performed by 22 swimmers. As a result of the training interventions, German swimmers at the 2011 World Championships in Shanghai showed the second shortest average changeover times after Japan. Strikingly, there were even highly significant differences to the teams from the USA, Russia, and France, which were among the strongest swimming nations at the time. related to their relay start performance as measured by the time between the incoming swimmer's wall contact and the outgoing swimmer's head passage at 15 meters, the German swimmers were able to reduce their off-the-block performance on average by 0.2 of a second as compared to their individual starts at the World Championships in Shanghai. In contrast, swimmers from other nations were only able to improve their off-the-block performance by on average 1/10 of a second. The performance gains for the first 15 meters in the previous slide, as measured by the off-block performance in relay starts compared to the individual starts, were also observed over the entire first lap. Significant differences between international swimming teams were found. However, no significant differences were found between Team Germany and any other nation. No main effect for gender was detected. However, a close to significant effect was found for the interaction of nation and gender. No such effect was observed within Team Germany. Adding up the performance gains during the start and the first 2 laps, it is clear that Team Germany shows the greatest differences between the relay start performance and the individual start performance compared to other nations. These performance gains are related to improved takeoffs from the block, changeover times, and most likely motivational effects during relay races as well. We detected highly significant differences overall between the nations. For the pairwise comparison, significant differences were only observed between Team Germany and Great Britain or France. There was no overall main effect for gender. However, a highly significant interaction effect was found between nationality and gender, which was also present for Team Germany. Thank you very much for your interest. This was the 3rd part of our 20 years of swim start research at the University of Kassel.